Welcome back, pre-calculus. Let's see, we are on number 14 of our original worksheet here, our review sheet. So this again, we've got all three sides. When we know all three sides, we can use law of cosines. So we're trying to find C. I'm going to start with the opposite of that, would be 25 squared. Is equal to 10 squared plus 7 squared minus 2 times 10 times 7 cosine C. All right, so that would be, let's see, 25 squared is, sorry, that is not 25, that's 5. I squared it when I wrote it up there. So 5 squared is 25. This would be 100 plus 49, that's 149. That's 2 times 10 is 20 times 7 is 140. All right, subtracting that 149 over, I got negative 124. It's equal to negative 140 cosine C. So C is equal to the cosine inverse, because I'm going to divide off this 140, 124 over 140. Crunching in that calculator, or into the calculator, I get 27.66, 27.67. There you go. All right, this is the part that's on 4.6 that you will see on your test tomorrow that I forgot to put on the review sheet because it wasn't on the review sheet from last year, but that's because they did it on a different test last year. So for 6, 7, and 8, we are matching up the graph of arcsine, arccosine, and arctangent. So remember, for arcsine, our domain is going to be from negative 1 to 1. But on the unit circle, the angles that we're talking about are negative pi over 2 to pi over 2. When we're at negative pi over 2, our sine is at negative 1 on our original graph, so this would be the inverse point. So here, let's draw it out this way. Here's sine, right? We know it's restricted between negative pi over 2 and pi over 2. It should be at the point 0, 0, so I know automatically it's not B or D. So then it's either this one or this one. We know sine oscillates from negative 1 to positive 1. And so I'm going to take these guys and I'm going to be looking for their opposites on my graph. So at this point it's negative pi over 2, negative 1. I should have a point on my inverse graph that's negative 1, negative pi over 2. Same thing over here. If I've got pi over 2, 1 on my graph, then the inverse should have 1 pi over 2, 1 pi over 2 on it. Notice these guys go on and on forever, so that is not it. Arcsine is A. Arccosine does a similar thing, except for we restrict arccosine or cosine inverse between 0 and pi. So we know it's not these guys. We know it's either B or D. But just like sine has endpoints at negative pi over 2 and pi, cosine is going to have endpoints at 0 and 1, or 0 and pi. So we're looking at this guy here, because this guy goes on and on forever. So for cosine inverse, we're talking about D. C is tan inverse, or arctan, because it's going from minus pi over 2 to pi over 2. It's got those asymptotes. Notice this one has asymptotes instead of these lines saying this is pi over 2. These are actual asymptotes. This guy goes on and on forever because of our tangent graph. This is what it looks like with those asymptotes. So when I turn it on its side, these ends are going to go on and on forever. In other words, my domain of this guy is from negative infinity to positive infinity. My range is from negative pi over 2 to pi over 2. So this is C. All right, let's answer 2 more about the domain of arctangent. All right, the domain of arctangent is from negative infinity to positive infinity. We just talked about that one here. For the range of cosine inverse, we said this was our cosine inverse. The range is going to be from 0 to pi, right? Domain that we restrict on cosine is 0 to pi, which means the range for the inverse is going to be from 0 to pi. And so we're talking about D. All right, on the last video, I'm going to come back and do all these other inverse problems. And then that'll be the last video you'll be ready to go for tomorrow.